Hello, everybody. My name is Agnieszka. I'm talking to you from Helsinki. I'm originally from Poland. I arranged my talk around several questions. The first one is, who is this talk primarily for? The second, what are we going to do? The third one, what sort of things to look out for? And the last one will be a series of questions and comments from you, hopefully. So this talk is primarily for those of you who are using Moodle as a virtual learning environment, or those of you who have a possibility to use it. Also those of you who use Stack, which is a question type for Moodle, or those of you who would like to use Stack. And also those of you who would like to maybe implement a longish exercise in Stack. So we'll take an example of a longish exercise, which will be an application of Ethos Lemma, and hence the title of my talk. So things that we will need today are Moodle with Stack plugin. So you can use conference website to practice, and also Maxima installation and Maxima is the computer algebra system behind Stack. There are also things that will be helpful, but not necessary. And these are some basic experience with Stack. If you don't have it, that's okay. You can follow Authoring Quick Start. There's a link here. So then you can maybe go over this and come back to my talk, my slides, and also basic knowledge of Maxima. So what are we going to do? We'll start by going over this longish exercise, which will be the statement of Ethos Lemma, and it will be given in a general case. Then we are going to take a specific case of this lemma, so applied for a particular situation. And for that specific case, we will do a sequence of steps. We'll begin by numbering answer boxes, because it's a longish exercise from 1 to 14. And this will be mimicking a situation where we have the solution to that exercise sketched on a piece of paper or in some typesetting software. Then we are going to code that solution in Maxima. And only then we will code the question as a Stack question on Moodle. Then we are going to modify the question a little bit to introduce some randomization. And this will be done through modifying Maxima code. And finally, we will look at some final touches where we will refine and finish. So
sorry, Agnieszka, can I just stop you for a second? I had someone message me saying that they can only see my screen, not yours. So we're just going to stop for a second. Would you mind turning off your screen share?
Yeah, on my screen it says you are screen sharing. So
yeah.
Okay, I'm going to hit stop share.
Okay, and I guess start screen sharing again, because it looks like I'm not at the moment. So yeah. Okay, and could somebody else just give me a thumbs up or something if you can see Agnieszka's screen now? Yeah. Colin says yes. Good. Okay. Sorry. Carry on, please, Agnieszka.
All right. Well, normally everybody asks, "Can you see my screen?" and "Oh, can you hear me?" So I assume that the default answer is positive, and if something is not right, somebody will say. So this is exactly what happened now. Okay, so maybe I'll go to the start just to give an overview again. So we are answering these questions. Who is this talk primarily for? I just described what we're going to do. And now we get to the juicy part of the talk. So let's have a look at this Ethos Lemma. Given an Ethos process, so xt with braces, so it's a continuous process in continuous time, t is time. It follows the stochastic differential equation here. So we think about dxt as a change in this process. Then we have dt part, dzt part. dt is the corresponds to a small time change. dzt is a change in the Wiener process. So zt with braces, this is a Wiener process, also known as Brownian motion or standard Brownian motion, which essentially is a normally distributed random variable with mean zero and standard deviation square root of dt. So these are the two parts. And then we have functions a and b of two arguments. A function is known as drift, b as diffusion. They should be well behaved. So we start with this process called eta process. And then we have a new process, gt, with braces. And the random variable gt that makes up this process is obtained by taking a function g of two arguments, transforming xt, which comes from this initial process, and transforming time. So we have this new object here. And this eta lemma basically gives us the stochastic differential equation for this process gt. And it is also an eta process. It has this drift part and diffusion part here. So dt and dzt parts, the drift part is a little bit bigger. There are some unexpected terms here, like this one, which come from how stochastic calculus works. But anyway, to apply this lemma, we need to know how to, first of all, identify functions a and b in the starting equation, then how to find the partials, which feature here, and finally, we need to know how to plug the elements from parts 1 and 2, simplify, and hope for the best, that hope that we'll get something fairly nice at the end of the day. So we'll take maybe I'll keep the two of them displayed. So we take a specific application. So we switch the notation from xt to st. S for stock price. T, we can think about time expressed on daily frequency. And this eta process, this initial one, is described by this stochastic differential equation. So the function a is just a constant times st. Function b is just a constant times st, mu and sigma constants. And then we have a square transformation. So g function is just taking st and squaring it. So time doesn't appear there as such. And this new random variable gt gives us this new process. And now our job would be to apply eta's lemma to come up with the stochastic differential equation for the process dt. Just one comment here that st described by this equation is known as geometric Brownian motion. So if you think about looking at the graph of a stock price on a daily frequency, this is what the typical trajectory of such process would look like. Okay, so now we have this exercise. You can think about some exercises from your courses that you would like to implement. And we start creating this exercise. So step A is to label the answer boxes. So I have a draft of the solution. So we assume that this is on a piece of paper rather than on Moodle. And so I have the first 5 boxes, which are functions a, b, and the partials. Then I have the slots that correspond to the elements appearing in the eta's lemma, and the final results, which is this new stochastic differential equation. So I'm numbering them in chronological order from 1 to 14. And this will be useful later to keep track of various elements in stack question. So that's the first step. Second step is to code this specific application of eta's lemma in Maxima. And I suggest that you do it in Maxima before you do it on stack, just because it is a longer exercise. So implicitly you will have several terms, and also you have time to think what sort of terms are likely to appear in the text of your question when you code it in stack. And also you have time to think about possible places where you could introduce randomization. So for example, in this specific question, I introduce a variable called var, which stores the symbol for the process, for the random variable that appears in the process. And here I we'll probably make it more general later by allowing this to be different symbols. So that's one place. Another place would be a power that appears on the square transformation. Maybe later I want to change it to something else than 2. But another place would be a pair of letters that appears in the starting equation, stochastic differential equation, so mu and sigma. I might want to have different sets of constants, and I'm declaring them here as this variable together, because if I think about what this equation looks like, I probably want to use symbols that sort of go together for those constants. So mu, sigma, maybe later I can use A and B, maybe alpha and beta, something like that. So when at some point I want to draw at random, I want to draw pairs. So I have this extra variable that stores a vector of 2 constants. So that's pretty much it. You can probably learn how to use maxima based on this paragraph and use it for your own exercise. So now I have a code in Maxima. I can check it. It's a free software, so you can install it on your machine, no problem. Then I'm ready to code it as a stack question. So I go on Moodle and I start a stack question. You have this beginner's quick start, so you'll be able to do it. So then there is a field called question variables, and this is where I insert my Maxima code. And I know it's going to work because I already checked it. And then I have question text, which appears here. So it looks a little bit long, it has some symbols, but basically once you get used to it, like with any syntax, you will be feeling comfortable. So so it also uses LaTeX here. This text, this is how we refer to variables that come from Maxima code, and they will be displayed nicely as ST, and they'll be rendered nicely in LaTeX. And you will see other places where Maxima variables are used. There are also sequences which allow us to insert boxes, and these will be tagged with this numbering that we had from the first step A. So in these places in the text of the exercise, we will have boxes. And then there is this middle part, which is quite dense because we have several boxes that in which we place the terms, various terms that appear in the statement of Ito's lemma in its final stochastic differential equation. So again, if you have this available, you just copy and paste and adapt to your particular exercise. So one item that I would like to bring forward is how to deal with potential response tree. And again, you need to know a little bit about stack. So this is for parts 6 and 12. So the suggestion is to use 2 modes for these parts. So let's go up to see what these parts are like. So these parts 6 to 12, these correspond to places where we plug in earlier answers. So this allows the use of 2 modes allows you to introduce the so-called follow-through marking. So you can give partial credit to the student if the substitution was correct, but maybe some of the initial answers, those first 5 ones, were not. So again, this is like a more technical detail of a stack question. So that will be one comment. And now we are ready to do a little bit of randomization. So we go to the Maxima code, which I guess also means that we'll be modifying question variables field. And here are the places that we can change to introduce a bit of variation. So I can draw a symbol for the letter for the random variable from the initial process from this vector of variables. And again, there's always an issue how to name the variables. So st, ut, vt, yt, we probably want to exclude xt because it appears in the statement. Maybe there are some symbols we want to avoid. Here we have a selection, a random selection from vectors to element vectors. I have here a pair EF. Perhaps it's not a great idea because letter E is interpreted as the exponential. So again, this is up to you. Then you have this dilemma whether you want to introduce Greek letters on top of just the regular letters. So these are the usual challenges that we have. And finally, we have this power here. So before we had 2, now we can have random selection. So we have integer power, we have positive, negative, and you can decide if you want to have a mixture or just positive maybe. And otherwise, everything remains the same. And in fact, this is the only thing that you need to change to have a richer class of exercises within this particular example. So a few more things to finish off. I would suggest to disable so-called show the validation field for parts 6 to 12. So again, these are these parts. When you start in Stack, when you start answering, putting your answers in these boxes, you'll get an additional pop-up box that says, that sort of controls, that tells you what sort of variables you're entering. So this makes the page quite busy if you have a multi-part question. So this sort of validation is fine for the first 5 answers, but because this middle part is quite congested, perhaps it's a good idea to disable this feature. So this is just a suggestion. And then there are the usual things, so whether the question is correctly stated, whether it's free of grammatical errors, names of variables, choice of constants, and other things that we are randomizing. Now, if you are thinking about having a Moodle quiz that covers a longish exercise, you probably want to have some warm-up questions. So in this case, I may wish to have some simpler exercises where students practice with identifying functions A and B, maybe refreshing their memory when it comes to partials. And again, the letters are quite challenging because we are not differentiating function f of x. The symbols are a little bit different. The notation is a little bit maybe more overwhelming. So perhaps it's a good idea to practice. So you can have a look at the quiz that I made on the conference website to see the quiz. So you go on software demos. Christian mentioned it yesterday. You have Ita's Lemma here in Stack. You have some introduction, and then you can have a look at the questions. That's the last question, number 5. There are some warm-up questions. So that's all that I wanted to tell you today. Thank you very much. If you have questions, comments, then you can email me or post questions on Moodle forum of the conference.
Great, thank you, Agnieszka. Yes, so as Agnieszka said, the questions are available on the conference Moodle. I've put a link to that in the chat. Certainly have a go through it. I tried before, I've never heard anything about this lemma before, so I was having to work out on the go what exactly I had to write for the answers, but it looked like it all worked. I can't see any questions on the Moodle site yet. So one question I have is, have you tried this on students yet?
I have.
Okay, and did you get any feedback from them about it?
Yes. There was a lot of negative feedback about the syntax in general, because I'm the only person at my university who uses Stack. So students are unfamiliar with entering algebraic expressions in e-assessments. So maybe there are some e-assessments that my colleagues have with our students, but not in Stack. So I had to really stress the fact that the syntax, what the syntax is like, and how to enter the answers. Mm-hmm. So that was that. Yeah, that was sort of one kind of issue with my students. I work at a business school, so you have to be a little bit more forgiving, perhaps, when it comes to syntax and math skills.
Yeah, certainly, I know that feeling. So once they'd got past the syntax problems, did students find these questions helpful for understanding Ito's lemma?
Yes, for using it, I think, because of course we start with a session where it's we have some materials where it's there's an example of it. So there are some slides, there's some material. Then we have a session together in class that uses Stack questions to practice. So we do it together. But they practice with Stack questions already then. So this is just as a teaching material or as a teaching tool. So we do it together. And then I use it for assessment. So it's continuous assessment during the course. It's one of the quizzes that I have with my students. It's dedicated to this lemma. And it works fine.
Good. Great. Well, thank you. I still can't see any other questions on the Moodle site. So I think we've got plenty of time in the rest of this session for people to come up with thoughts about this. So thank you for that insight into the process of writing quite a complicated question. I think it's good to see all of the stages of the design of a quite sophisticated e-assessment question.